Hello everyone, I want to show you how to visualize a cross product using Desmos. A cross product is often hard to learn when you're first seeing it for the first time. It can be confusing. So let's look at a way to visualize it in 3D because frankly you need to look at it in 3D. So if you go to Desmos, if you click on the math tools, they have an option for a 3D calculator, which is really nice because you can start putting vectors on here and then you can turn it around your coordinate system, right, X, Y, Z, and you can see more or less in 3D what something would look like. So let's start doing that. You can put in a certain vector, let's call it A, and all you have to do is type in vector, and what it really wants you to do here is to put the end points, so the starting point, comma, the ending point of a particular vector. So you can start at 0, 0, 0, x, y, z, and then go to 0, 2, 0. Okay, and so now you can see this vector in red is A, right? So it's in the y direction, right? Why? Because it starts at 0, 0, 0, and the only value is the y component, so it has it points in the y direction, right? So it has just one component in the y direction. So it's nice. So now you can start seeing a vector. If you want to make adjustments, if you click and hold this right here at the end, what you'll get is options to change the colors, or if you want to change the line width, you can do that. So it will get set at 2, just so that it makes it easier to see. Okay, so let's put another vector. If you hit the down arrow, you can say b is equal to vector, and again, the endpoints, the beginning point and the end point. So again, we'll start with 0, 0, 0, and let's put 0, 0, 2. And feel free to make up whatever you like. We're just doing this just to see two random vectors. We're going to take a cross product between A and B, and you can see the result, what you get from Desmos. Again, I'll click and hold to change the line width. Again, change the colors if you like. So we'll leave it as blue. And so now you have two vectors, right? So the red one is A, the blue one is B. And you can see, you can rotate, see what this looks like. And before you do the cross product, just think about what you expect to get using a right-hand rule, right? So there's the fixed finger method of doing this, where you would point your index finger in the direction of the first vector, in this case A, because we're going to do A cross B. So the index finger should go along the direction of vector A, which is in red. Your middle finger should go in the direction of B, which is the blue one, and your thumb should be the result, right? Let's call that C, right? The A cross B vector. So you can start thinking about what direction you expect to see this, right? So you can rotate around if it helps you to see, right? And then imagine where vector C, the result of A cross B, would point. If you like the other method of doing the right-hand rule, the curling your four fingers, the four fingers on your right hand go along A to start with. You curl your fingers towards B, the blue one, and again, your thumb still is the result, right? So they're the same, it's just some prefer one or the other. They give you the same result at the end of the day, right? So start doing that just before you make Desmos. Desmos can do the cross product for you, but the point of this is to practice doing your right-hand rule, right? So let's go and put in vector C, which is the result of A, and all you do is hit space and just type in cross, right, for cross product, and then say B, and then you get the result, right? So you can use your mouse or trackpad to zoom in and out of this graph, right, so that it makes it easier to see. Again, click and hold to adjust the line properties here, right, for this vector. Now it makes it clear, right, what this is. Adjust the colors as you like, right? So hopefully this is what your right-hand rule told you A cross B was going to be, right? So again, use your right-hand rule, check yourself, right? And when you're trying to do the right-hand rule and you're trying to draw this on paper, it's much harder. So hopefully this 3D version of it is easier to see, right? So try it with either way, right? The fixed finger method or the curling your fingers method. Either one will give you the same result, right? So you get A cross B is C, right, shown in green here. You can also just test yourself, right? So then if we kind of click and make C disappear for a second, you can change what A is. You can say it's the negative of what it previously was. So in previously, we have A, the red vector, pointing along the positive Y direction. If we put it as a negative, right, it will flip and be on the other side. Now, think about what A cross B should give you in this case, right? So again, practice your right-hand rule. Try to do A cross B before you see the result. Desmos will do this for you, but the point again is to try your right-hand rule, right? Get familiar with it. Okay, so then if you turn this back on, you'll see that's the new result of A cross B, right? Again, try your right-hand rule. Okay, so far we've only kept these vectors fairly simple. They point along either one of the XYZ coordinates, right? So they're simple, and you might ask the question, well, can it be more complicated? And it can be. So what we'll do is remove these and start a new one, call that D, and let's say that's a vector that starts at 0, 0, 0, goes to 0, 2, 2. Okay, so new vector. This one is in purple. And then we'll have E is equal to vector that starts at 0, 0, 0, and ends at -1, -2, and 1. I'm just making this up, just trying to get random vectors so that I can start seeing what the results would be, right? If I am trying my right-hand rule on more complicated situations, I'm going to get more familiar with it, right? It's good to practice. Now, you'll notice if you rotate this, right, you're looking at the x, y, z coordinates, right? And look at these vectors. They're not just in x or just in y. They are pointing where there are components in different directions, right? So there's some components in x, some components in y, and so on, right? So here are the two vectors, D and E, and what we're going to do is find the cross product between D and E. So D cross E. Do the cross product, right? So try out your right-hand rule. Which way do you expect, let's call it F, to go? So F is what we want it to be. We want D cross E, okay? So let's take a look at that, right? So look at where the resultant vector points, right? So we're doing D cross E, the purple one, crossed with the orange one. And the green arrow, the green vector, is supposed to show you the result, right? So of the cross product. You can use your right-hand rule, see if you get this result, right? Either one. So again, take your, if you're doing the fixed finger method, take your index finger, point it in the direction of D, the purple one. Middle finger goes along the orange one, E, right? And the order matters, right? So if you do D cross E, that's one scenario versus if you reverse it, if you do E cross D, that's different. So D cross E, index finger is in the direction of D, purple, and the middle finger is in the direction of E, which is an orange. And you should get your thumb to point in the direction of the result, which is F, which is shown in green, right? And then rotate it around, right? And you can see these vectors a little bit better. You can also use the curling method, right? So that is starting your four fingers on your right hand along D, the purple one, curl your fingers towards E, the orange one. And again, your thumb is F, the result should be pointing the way that is shown on Desmos, right? So the more you practice this, the better you're going to get with using the right hand rule. And I'd encourage you just to make up your own vectors, right? Any two, take the cross product between those two, and then see if you can, before Desmos does it, predict what the result should be. And that way it's a good test for you to try this out, right? So you can make simple adjustments. You can make E negative, right? Pointing the opposite way, right? So notice what happened to vector E, and then as a result, the cross product is also different, right? So the result is different as a result of having a different E. So try this out yourself. I think this is a good way to visualize a cross product, and hopefully that helps you understand the direction of a cross product by using Desmos, by plotting out these vectors.